In this video, we're going to talk about CRA models for integer addition reasoning. So we're going to start with some simpler examples. We have three different problems we're going to look at, all with negative signs in different places. So an integer just includes whole numbers and then all the negative numbers as well. So whole numbers again is 0, 1, 2, 3, and so on. And then negative numbers is obviously just going to be all of our whole numbers, but just with the negative sign, so the opposite of those. So that's what we want to focus on for these operations here, is interpreting this negative sign as meaning the opposite of. Okay, so we'll show a concrete model. We're going to use our two colored counters with the 10 frames. Representational, we'll use number lines, and then we're just going to use the numbers and symbols for the abstract model as well. So this first one, we have 5 plus -3. So again, all these are going to be for addition. So we're starting with 5. Again, we usually say yellow means positive, and then our red for the two color counters means negative. So again, since we're adding, we have these two groups. We have 5 here, -3 here. So to combine these or add these into one larger group. So we can do this in the same way that we would add normally, or if this was just 5 plus 3, we would just add these together. So we can combine these into one group, and then we have to interpret what the meaning of this is. Right. So again, we have 5. We didn't have 5 plus 3. We had 5 plus -3, or 5 plus the opposite of 3. Again, the opposite side of 3. So looking at just kind of zeroing in on each of these yellow and red pairs, we refer to these as 0 pairs. The reason we refer to them as 0 pairs is because they add or sum to be equal to 0. So if we have 1 plus -1, or 1 plus the opposite of 1, these would add to be 0. So this is a 0 pair. So this little portion, this column here, is equal to 0. So we can remove this from the quantity. We don't need to keep this in here since it's equal to 0. It will be the exact same thing if we take it out. Okay. Same for that second 0 pair and that third 0 pair. Okay. So then what we're left with is just two yellow counters. So then our sum, or our answer, is just going to be 2. Okay, so that's the concrete model. We'll look at a representational model, again highlighting this idea of the opposite. So in our representational model, we have a drawing of a number line. So we have 5, we're starting at 5. To add the opposite of 3. So normally when we're adding, that means we're moving to the right. So if we're adding 3, we would move 3 to the right. Here we're adding to the opposite, or adding the opposite of 3. So we want to move the opposite direction. So instead of moving 3 to the right, we'll move 3 to the left and end at 2. Okay, so that's the representational model. And then for this, for our abstract model, I'll show one of kind of the more expanded versions. We could write 5 plus -3. So essentially what I did in that concrete model was I thought of this as, I won't go super expanded just to show each 0 pair, but I changed this into 2 plus, and then the quantity 3 plus -3. And then this 3 plus -3, right? Those are our 3 0 pairs. Those are equal to 0. Sorry, this is 2 plus 0 over 2. A little glare there. Okay, so that's our first one. Second one we'll look at, we're just going to move the negative sign around a little bit. So here we have -5 plus 3. Again, we'll use, for the concrete model, we'll use the two color counters. We'll start with -5 on 1, so 5 reds, and then +3, so we have 3 zeros, or 3 yellows. Okay, so again, we're just combining these into one larger group, same that we did with whole numbers. Add these together, and then again, we have to interpret what these mean. This is -1 plus 1, those would add to 0. That's a 0 pair, another 0 pair, and then the third 0 pair. So then what we're left with is just 2 red counters, or -2, or the opposite of 2. Okay, so that's our concrete model. Representational model, again, we're going to look at a number line. So we're starting at -5. And here we're just going to add 3. We're not adding the opposite. So when we're adding, we're moving to the right on the number line. So we're just going to do that same thing here. We'll move to the right 3 places and end at -2. And then for our abstract model, again, essentially what we were doing here was we decomposed that -5 into -2 plus, and we had -3 plus 3. So we were kind of associating these two together, the opposite of 3 and 3, or -3 and 3. So again, these are going to be those 3 zero pairs, which is why we end up at -2. Don't forget the negative. And then our last version is where we have negative signs for both of our 2 add-ins. So again, we'll use the 2-color counter for our concrete model. Set this up right away. So you have -5 or 5 red counters, -3 or 3 red counters. So again, we're just adding these together, just like we did in kindergarten. Right, add those together. They're all the same color, so that means there's no zero pairs. None of these, if we pair these up, none of them will be equal to 0. So what we have is 8. That's 8 what? 8 red counters, 8 negative counters. So our sum here is going to be -8. Okay. And for our representational model, again, we're starting at -5. Those are our starting amount here. We're going to add the opposite of 3. So again, adding not the opposite, so we're just adding our normal amounts. We're moving to the right. Adding the opposite, so we're moving to the left. 3. Okay, so you get -8. And then for our abstract model, for this one, right, there's no zero pairs. And so it'll just be our equation, -5 plus -3 equals -8. So again, concrete model, those 2-color counters are good for these simple examples. If you had larger add-ins, you could use base 10 blocks that, oh, sorry for the glare here, base 10 blocks that have different colors, so like blue and orange. Kind of do the same idea as far as zero pairs there. Representational number lines are really good to highlight that opposite idea as well, so opposite directions, and then abstract is just going to be just the equations.